discussion is called From Mosaic to Modern, the Evolution of Web Application Architectures. So what we'll be talking about today is a little bit of history. There's that saying that says that if you don't know your history, you're doomed to repeat it. And I think we see that a lot with software in general. So what I'm going to do is take you on sort of a journey back to the early days of the web, and look at how our architectures have evolved over time, and then also look at what's different about the way we do things now versus what we did then. So it should be a nice little journey for everybody. A few words about me. Kate said most of what's important. The podcast is called the Stacked Podcast, so if you like podcasts, you should check it out. It's me, Daniel Hinojosa, and a couple other people, and we also interview folks as well. We do front-end and back-end talks about, just technology in general. And I'm a Java champion and stuff like that. Okay, so before I get too much further, how many of you have been working with the web technologies for over 20 years? All right, good. How many people have been working with web technologies for over 10 years? Okay. How many people over 5 years? How many people less than 5 years? Okay, excellent. You're definitely in the right place then. So I will definitely say I'm one of those 20 years plus people. So I'm going to take you on a journey over what I've seen over the years and some things which I've learned along the way. And I want to give some special thanks to Wikipedia, which is an amazing resource. So especially if you're trying to find dates on when technologies appeared. Shout out to Wikipedia, definitely. Okay, so I'm going to take you on a journey, and this journey is kind of long, but we've only got an hour, so I'll try to be quick about it. And I did want to say one more thing, actually, which is that when I started thinking about this talk, I'll take you away from that for a minute. I was thinking, well, what I want to do is talk about different architectures, right? Because I do a lot of architecture, but I also do development, and I've built lots of different web apps over the years. And I thought I would look at the different forces over time that have affected the architectures of web apps. But as I went through it, I started realizing that the forces actually are linear, right? There's a timeline associated with it. So what I'm going to do is look at things more in terms of the actual timeline, and then talk about the architectures as they changed along the way. Okay. All right. So we'll start our story in 1971, before I was born. The Advanced Research Projects Agency Network in the US, ARPANET, was created. And the initial people thought that the idea behind it was a distributed network. It was the precursor to the internet. And people thought that, people later on said, well, it was developed to withstand like a nuclear war, right? So that parts of it would still be working if, different areas blew up. But it turns out it was really just more to connect disparate research institutions, right? There's a lot of research going on. A lot of it was related to defense, but they wanted to be able to connect the different universities to share research. And that was the initial impetus for ARPANET. So that was 71. Another thing that's important for our discussion is 1970s. And has anyone heard of Smalltalk before? Oh, wow. Okay, so one person sort of heard of Smalltalk. Okay, so Smalltalk was or still is an object-oriented language. It's super object-oriented. It's really beautiful to work with. Of course, I only learned it at university. I never had a chance to use it in production because it's not popular. But in the 70s, it existed, and that's actually where the whole model view controller concept came from. Having, a view to display it, a model with the data, and a controller to mediate between the two. So that's where it all started, back in the 1970s. And back then, of course, there was no internet. It was not related to web applications. It was just related to desktop applications, okay? So that's where it all started. So fast forward, 1986, ARPANET sort of, and other networks in other parts of the world merged into NSFNet. which was really more about, just basically sharing research and everything, right? It's, became less defense oriented, etc. And then around 89, all these networks emerged into what we now know as the internet. Okay, so this is sort of the genesis of everything. And initially, it wasn't a commercial entity. It was mostly, and actually legally in some areas, restricted only to universities and stuff like that. So, you went to university, you could access the internet, and you're like, wow, I have email. That's cool. But outside of university and government, it wasn't really a thing. Okay. Another significant point was Windows 3.0. Anyone remember Windows 3.0? Okay, so one person. All right. So initially, if you go back in the early days of computing, if you got a PC, you would have DOS, right? You'd only have the command prompt. You could run programs, right? And those programs would look better than DOS, but they weren't really pretty. It wasn't like a graphical display like we know today. And the Macintosh had that. But Windows didn't, or PCs didn't, and PCs were dominant at the time. So Windows 3.0 was the first version of Windows that actually had a real graphical user interface. And with Windows, you can drag around and like everything. And that was the first version of Windows that actually took off. And the funny thing about it was that you were in DOS and you basically just run Windows as an application. And then magically you had a desktop and stuff like that. So it was an interesting time. But it's important because it was the first real sort of mass market graphical user interface, whereas Mac was sort of a niche at the time. So. And then 1 year later, we got the World Wide Web. Okay, we'll stick with World Wide Web here. All right. And this is actually the original logo for the World Wide Web. It was invented by Tim Berners-Lee at CERN in Switzerland, which was a research institution. And that's where HTML and HTTP came from. Those are sort of the two main things. And they wrote an initial version of the browser and the web server and everything. Okay. But you'll notice that there's a couple key things here. Well, first of all, is that the web and HTML was built around hypertext, right? And HTML wasn't even like new. It's a very slimmed down version of something called SGML. So basically, they took SGML, which was a markup language, slimmed it down into a very specific instance of it for the web called HTML. And remember, it's hypertext markup language, right? So the main innovation here, over and above the distributed protocol for distributing data, was really the hyperlink. There have been other hypermedia systems before, and I remember actually playing with one back in the day. But this was the first sort of universal one, right? The idea that you could link from one document to another on an entirely different server was really, really amazing at the time. Okay. And the other key thing is that if you look at what it says there, what does it say? It says, it sort of does, let's share what we know. Okay. So it was all about information. It's about sharing information, sharing data, sharing documentation, research, that kind of stuff, right? It wasn't about let's build a cool app to check into a flight or, bank or whatever. It was about let's share information. And that was really the nexus of the internet, okay? Of the web, I should say. So around that same time, 91, we had a couple other important things. We had Power Builder and Visual Basic. Anyone heard of these before? All right, so a couple of you. So these were what we called rapid application development tools back in the day. And what these would let you do is very quickly build applications that ran on Windows, okay? And one of the key innovations that they provided was having UI components. They had like a palette of UI components that you could pick to work with, like data tables, surprise, surprise, input controls, drop-down lists, tabs, whatever. All the sort of rich UI components that we're used to talking about, okay? And they made it really easy to build applications. And these really took off around that same time, okay? And then around 93, that was when the web really started taking off, right? So it was in research institutions at universities, right? But then in '93, something amazing happened. The NCSA developed the NCSA Mosaic browser. Okay, and this basically means National Computing Center or National Center for Supercomputing. And there were a few different around the U.S. at the time. And Mosaic was the first web browser that actually was attractive and easy to use. Because you can imagine, Tim Berners-Lee, 91, he wrote something that ran on Unix, wasn't the prettiest thing in the world, but it worked, right? But Mosaic actually ran on Windows and on Mac and on Unix, okay? And it looked great. It was easy to use and everything. So that was a big deal because that was when people started really seeing the power of the web. They started jumping in and looking at websites, et cetera, et cetera. NT came out then, Windows NT, and Windows NT was significant because it was sort of the Microsoft server technology, okay? And around that same time, they also realized that, hey, it might be good if we're looking at a web page, right, to have dynamic data, right? So why don't we create a gateway so that when we're looking at data, when we're looking at a website, we can have a gateway to the rest of the data in our, on our server, right? So they built something called Common Gateway Interface. And this was a way for a web server to call an external process, a whole external process, usually like a Perl script or C or something like that, that would go and get data and then display it back. Okay, and this was the first way that we could actually extend the web server to provide real dynamic functionality. Okay, but at the time, the functionality was launching a new process, not particularly fast, right? And then, of course, there are all sorts of other constraints that we had at the time that we don't have now. Okay, one of the main constraints being dial-up. So back then, if you wanted internet access and you weren't at a university or a company that had a lot of money, you basically had to use dial-up internet, which means you would use your phone line and your modem and call and get on the internet. And the speeds were very slow, so there wasn't a whole lot you could do from as a consumer back then. Okay, but around the same time, things were going pretty cool on the desktop world. Okay. So I talked about Visual Basic and I talked about Power Builder, right? And those were desktop applications. Those are what we called fat clients at the time. And the reason they were called fat clients is because all of the entire application functionality was one application, right? And it was fat, meaning that you had to install it. And usually the installation process was a pain in the butt. And inside of a company, the process of installing it on lots of servers was kind of a pain, okay? But if you had a local area network, you could actually have on your Windows NT server or whatever, a database. And that database would allow you to basically have what we call client server. And the difference, though, is that your desktop app would talk basically directly to the server, right? The desktop app would make SQL queries, okay? But this was a lot of how we built applications. You had your thick client, it had all this rich functionality, had a great UI, and it would just talk to the database. Pretty simple, but the deployment process was a nightmare, right? You had different drivers, different versions of operating systems, all sorts of fun stuff, okay? So then we get to 1994. And 94 is when Netscape came out with their browser. And Netscape was started by one of the co-founders was Mark Andreessen, who was actually one of the NCSA Mosaic developers. Okay, and there was another one that joined him as well. Okay, so they went to Silicon Valley, they started this company called Netscape that made this cool browser, and everybody thought it was the best thing ever. I remember installing it on all the computers, we thought it was great. And Netscape pretty much dominated. It kind of killed Mosaic. Everyone thought it was the best thing ever. Okay, and around this time we also had the World Wide Web Consortium, W3C. Does anyone know what W3C does? Okay. So a few of you, all right. So W3C is a standards body, and this is really key about the evolution of the web. because the web is built on open standards. Okay. So W3C started actually maintaining standards for HTTP, HTML, all sorts of other technologies that we work with on the web. They did XML as well. Okay. So W3C is still very popular, a very important force in the way we will build web applications today. Okay. So we get to 95, and things get really interesting. Okay. And actually, before we do that, there's one thing I want to mention. Actually, let's talk about this first. Okay. So 95 gave us Borland Delphi. Delphi was another tool like Visual Basic or like or Power Builder or something, but it was a whole lot better. We thought it was even the best thing since sliced bread. The language is Turbo Pascal or Delphi Pascal, whatever you want to call it, but it was pretty cool. Windows 95 came out, which was a much, much better version of Windows. But the key thing here is Internet Explorer. Internet Explorer has a very, very important role to play in terms of the way we build applications. Okay. So that was Microsoft's first version of their browser. They actually licensed it from another company called Spyglass. They also introduced Internet Information Services, which was their web server. Cold Fusion came out around then. Cold Fusion was one of the first tools that let you build an application on the server that would basically integrate with CGI and then grab data from the database for you and then display something. Okay. So that was very important. Same thing goes with PHP along the same lines, right? Anyone written PHP before? Okay, so a couple of you. So PHP again is basically a server-side system built integrated into CGI, runs through the web server that will allow you to add dynamic logic into your pages that can grab data and do conditional stuff and business logic and stuff. Okay, not the prettiest applications with either of them at all. A lot of spaghetti code, but the idea was that you could quickly build pages and then talk to a database and do whatever else you had to do. Okay. And at the same time, HTML2 came out. And HTML2 was very significant because it gave us this very, very important thing here called forms. Okay. So remember, we're at a point where we basically have single documents, right? You can go, you can grab, you can make a request, you can get some data back. That's pretty much it. And of course, now we know through CGI that it can be dynamic. But essentially, we didn't have a way to submit data other than like query parameters, right? So now we can actually submit data. We have actual forms, we have input controls and everything. And this was really when we started to say, okay, well now we can actually build some sort of application, right? And that same year, we had a couple other things. Okay, so this was a very important year. We had the Shockwave player, which allowed us inside of a web page to do multimedia content, games, that kind of stuff, because the web browsers had started having browser plugins, right? So just like we have extensions, they had browser plugins is what they called them, and they would allow you basically to circumvent the browser, the HTML part, and do other things, right? So Shockwave was a platform for building multimedia applications. Java came out that year as well. And one of the smartest things they did with Java was Netscape got excited about it, and they integrated it into the browser so you could have Java applets running in the browser, right? And that was a big deal. And if you look at what's happening here, it's like now we've gotten to a point where we have HTML, right? It was great for documents, great for that kind of stuff. Then we're starting to slowly make them dynamic, slowly add some integration of user input, right? They were also saying, well, we want to build cooler things, so let's use these escape hatches of plugins, right, to add Java applets and Shockwave stuff as well, okay? So with those technologies, you could make things even more powerful. You could do animations, you could do games, you could do all sorts of things that HTML just couldn't do at the time, okay? And seeing this, Netscape introduced JavaScript. So JavaScript 1.0 came out then. because what they knew is that they wanted to provide the ability for the web to be dynamic. So they took two different strategies. One was applets, one was JavaScript. Okay, but as we all know, JavaScript 1.0 not super powerful, right? You could add some scripting, but you couldn't really build a whole application with it. Okay, but what we did get is our first web applications. Okay, so we had our browsers, they made requests, they might have an applet, whatever. It goes to web server, it goes to a CGI script, which launches a separate process and hits a database or whatever else, right? So now we have our first web apps. Now remember, each one of these is a full page refresh, right? And this isn't particularly scalable because each request spawns a new process, right? But we have the beginnings of what we're actually calling web applications today. I did also want to show you guys this, and if anybody is interested. So this was interesting. So this is the original announcement about JavaScript. So you can see Netscape 95 and 28 industry-leading companies to endorse JavaScript as a complement to Java for easy online application development. So that was an interesting find there. Okay, so 95 was really important. So then we get to 96, and we were having a realization that this CGI process, this idea of actually, creating a whole new process for each request, probably not the most efficient thing to do, right? So that's when we say, okay, well, maybe we should provide some APIs on the server side so we can have plugins that are faster, right? We can run things in process. There's no process per request going on. We can have one thread for each request. Okay. So that's when we had the Servlet API. In Java Web Server, there was actually a Java Web Server that was used that came out back then as well. They had the Servlet API built into it. We also had something called active server pages around that time. And active server pages were sort of like Cold Fusion, or PHP, but basically the idea that you could have really dynamic applications integrated with web pages. Again, a lot of spaghetti code, but that ran on the Microsoft platform. And we had these APIs. So we had ISAPI, INSAPI, and ASAPI. A lot of app SAPIs. So these were APIs that ran on the web servers at the time. So we had them running on Internet Information Services, on Netscape's application server, on the Apache server, etc. Okay. So those APIs allowed us to then have applications that ran in process of the web servers. Okay. And a lot of those were in C++ or in other languages or Java, as we mentioned, as well. So that's when we ended up with something a little more like this, right? So we had the browsers going to the web server, and then we had our plugin servlet process. So this is where things start to look a little bit more like what we have today, right? At this point, either we have this sort of plugin architecture or the web server is just the app server. It's the same thing, right? And the reason there was this distinction back then is because often a web application would have static content as well, and you wanted a way to be able to serve that as well, okay? Okay, so this is another big year. We also had first version of CSS and Flash. Flash was like Shockwave. It was another way to circumvent the browser and add a whole bunch of functionality, okay? And there was a whole ecosystem built around Flash and building rich user interfaces because having that escape hatch really gave you flexibility, right? You could do all this stuff based on an entirely different platform that wasn't just HTML. Because again, HTML really was only good at forms. It wasn't good at a whole lot else, okay? Forms and content. JavaScript is significant because it was the JavaScript variant in the Internet Explorer. Okay, so 97, we had ECMAScript, which was the standardization of JavaScript. This is where we know JavaScript is going to stick around because the key thing about open standards is that they pretty much ensure something has a very good chance of surviving long term. If something remains proprietary, if that company dies or gets purchased, it may get killed over time, right? So that was an important thing. And Internet Explorer introduced something called dynamic HTML, which basically was a whole lot of sort of proprietary HTML features to make things very dynamic, but it was only in Internet Explorer. Okay, and so basically this is when we started seeing a lot of features being brought to Internet Explorer that weren't available in other browsers. Okay. All right, so 98, we get to CSS level 2, which is important. We also get to XML and XML RPC, and which is basically using SOAP, Simple Object Access Protocol. And the importance of this essentially is the first time we had what we really consider web services. Okay, so these are processes which run, right? And the communication, though, was via SOAP. It wasn't via JSON, right? And SOAP uses XML, and it's a very structured format, kind of complex. But there was this WSDL file which would describe a service, so you could discover a service, learn about it, learn how to call it, learn what methods to call, all that kind of stuff, fun stuff. There was also this idea of a service broker, okay, which would allow you to basically, you'd ask the broker, hey, what are the services available? And it would tell you. Okay, that part never really took off. I will tell you that SOAP took off enough that I've actually worked with it in the last few years because we had some integrations to do. Okay, but the reason this is significant is because these were web services. That's what we called them. Okay, and REST wasn't a thing yet. And the reason this didn't stick around was really the level of complexity, right? So XML is considered verbose. It was very sort of heavyweight in terms of defining the SOAP endpoints. And the implementation details, there was a lot of code generation, things like that. It wasn't like you could stand up a service really quickly and then just respond to requests and return a response. Okay. So the overcomplexity kind of killed it. All right, so 99, we got CSS level 2, XML. We had the wireless application protocol and the wireless markup language. Anyone heard of these before? Okay, so a couple of people. In those days, we did have basic sort of internet capability on phones, right? But these were flip phones. These weren't like iPhones or Android phones, right? So in an effort to provide support for those, there was this slimmed down language called WML, and also a protocol called WAP that allowed us to have smaller payloads and allowed us to provide UIs that made sense for those types of devices. Okay, and sometimes we built applications that would actually display different markup based on whether you were using a phone or a desktop browser. Okay, because this was before responsive design, right? So. This is also around the same time the Web 2.0 term was coined. We got ECMAScript 3, and we also had something called Java Server Pages, which was sort of a copy of ASP, Active Server Pages. There's also when Java EE came out, and HTML4 with the iframe. Does anyone know what the significance of the iframe is? Okay, so a few of you. So initially, HTML earlier had something called frames, which were really sort of an annoying way to like segment part of the page, and each one could scroll independently. The iframes were like embedded, so they were cooler, and also you could sort of cheat and make external requests to the backend like sort of asynchronously with them. Okay, so it was a nice escape hatch for us. But the key thing is that now we're at a point where we're seeing that we can evolve and actually try and build real applications, but still, we're working with a platform which wasn't really designed for that, right? But it's evolving. So a couple things here. First, we had this Model 2 architecture, which was popularized with Java Server Pages. And basically the idea there is that you have a web browser, and it can talk to your server. You have servlets at the time. And the key thing about the Servlet API and also those other APIs like INSAP, et cetera, was not only did they provide you with a way to integrate with a request and response, but they also gave you filters and other endpoints, other ways to respond to the lifecycle of a request. Okay. So the idea was that, you had your JSP pages, and hopefully you didn't put all of your logic in them. Hopefully. Hopefully you put some logic in your model or somewhere else. And basically you could use a servlet as a controller to control between the view and the model. Okay, so it was sort of a web variation of MVC. And the reason they did it like this is because, remember, we're still at a point where every time you made a request, you got a full page back, right? So you had a full page refresh. So the idea of the initial MVC was really based on fine-grained events, like you click a button or, you press enter or something, right? But at this point, this is not a fine-grained event. It's like you're submitting the whole form or making a new request, okay? So that's why in Model 2 is like this. It was more about you make a whole request, and then we just ensure that we separate the different layers, right? So it's not one big thing, okay? So around the same time, 2000, we got the Java blueprints. Anyone remember those? So the Java blueprints were a whole bunch of architectural documents about how, like, patterns for building enterprise Java applications. We also had Apache Struts, which is one of the first sort of MVC frameworks for Java. For web frameworks. And again, the idea there was that you still did the full page refresh, but the framework let you handle things like routing, gave you a way to structure your code, right? So, you knew where to put your business logic, your controller logic, how to get from page A to page B, all that kind of stuff, okay? And that's also when REST was sort of coined, okay, around 2000. And around then, what we had was what we called the multi-tier architecture, okay? And the idea was that, you could have different servers that would have different layers of your application, right? So you could have your web server, and then you might have your presentation tier, which is, some sort of server-side web framework like Struts. That can talk to some other tier, which is like running EJB or something else, okay? And then that could talk to your data, okay? And this was a thing, you would say, hey, I'm doing an N-tier architecture, right? And if you think about it, this is, very much a precursor to what we're doing now, but these were all physical servers, right? There was no Docker. We basically had, physical hardware for all of this, okay? So 2001, and the dates on the right for broadband, those are kind of approximate, but we're starting to get some broadband, and we get Internet Explorer 5, CSS3 media queries, very important for creating responsive designs, right? And Internet Explorer 6. And Internet Explorer 6 is probably one of the most important web browsers ever, because it sort of stagnated things for a while, and we'll talk about that in a minute. But the key thing here is Internet Explorer 5 with the original XML HTTP request implementation, okay? So the purpose of this was basically to make Outlook web access work better. So Microsoft was, of course, trying to make sure that Outlook worked on the web with Internet Explorer, of course. And they put this little thing in there called XML HTTP requests so that they could do dynamic stuff with Outlook web access, okay? So that's where that feature came from, and that was the beginnings of Ajax, right? The ability to do an asynchronous request and get a response back. And it was called XML HTTP requests because you got an XML response back. That's what it was for initially, okay? So that was 2001. Quickly, the other browsers were starting to catch on about XML HTTP requests. But in the meantime, we got new versions of WAP. This is the version of WAP that actually had some actual progress or uptick. But this also marked the beginning of Amazon Web Services. So if you think about it, it's 2024. AWS is less than, is slightly more than 20 years old, right? And of course, the first versions of it were pretty simple, not nearly what we see today, right? This also marked the beginning of the .NET framework, and and ASP.NET. And ASP.NET was important because what it did was, of course, it was a way for building web applications, but it wasn't anything like ASP. ASP was more about, you have some HTML, you throw some code into it, and then you get a dynamic page, and then you have spaghetti code, right? ASP.NET said, all right, well, let's actually think about this as properly. Let's design something intelligently. Let's have actual UI components running on the server that can render something back to the client. And let's give you sort of a feeling of building, sort of like we had, in the 90s with, Delphi and Visual Basic and stuff. The idea there's a page with components on it and things like that, okay? So that was one of the first sort of major frameworks for what we called server-side UI components, okay? And all right, so we'll go on down here a little bit. All right, so that was 2003, 2001. 2003, we get Safari 1.0. We get something called the Portlet API. Anyone remember that? All right, one person, woohoo! And along with it, the web services for remote portlets and Java Server Faces 1.0. So Java Server Faces 1.0 was Sun and Java answer to ASP.NET Web Forms. That's what it was called. Okay. And the way they worked is they were what we call server-side component frameworks. Okay. And so I said the ASP.NET Web Forms is really what I was talking about, was sort of the first major UI component server framework, right? And Java Server Faces was sort of the second major one, and there were some other ones, some other open source ones as well, like Tapestry. But the way they worked is they said, well, okay, we've already had experience of building spaghetti code, right? That is integrated with pages, logic and HTML all integrated together with ASP and Cold Fusion and PHP, right? We also have dealt with server-side web frameworks like struts that gave us some structure, right? Where we had, maybe we used JSP or something like that as a templating engine, but we didn't put all our business logic there. We put it in actual classes, and we had something to do routing and things like that. Okay, so these frameworks took those ideas and said, all right, that's great, but we still don't have a good way to represent the UI. All we're dealing with is HTML. HTML doesn't have a data table component. HTML doesn't have a tree component. HTML doesn't have tabs, fancy drop downs, autocomplete, all that kind of stuff, right? So they said, well, why don't we build UI components that have those features, and we'll give them a way to represent, to render themselves in the browser, and then we can do logic on the server, and then we'll give them a little bit of JavaScript because there was JavaScript out there to make them functional, right? So we had server-side frameworks, and they would basically keep that component tree, that representation of the actual UI on the server side, okay? And then the web browser didn't really know about the UI components. It would have some JavaScript to provide that functionality, but there also, the only JavaScript was for the UI components, no business logic or anything. Okay. So this was around that 2003 time. The other thing that we had then was something called a portal server. Okay. And portal servers were a big thing around that time from a lot of big companies, right? Everyone had their own portal server and their open source ones. And this technology still exists, just not super popular. But what it allowed us to do was have one page that was visible in the browser, and that page could have multiple full-fledged little applications inside of it. They were called portlets. And within the UI for that page, you could collapse them, move them around, add different ones to the page. Sound familiar to anybody? It's a very common pattern with any sort of dashboard, right? So the idea, though, wasn't just that you would have the ability to have those little widgets on the page, but each one was a completely separate deployment. Each one was actually packaged as a WAR file, okay? The portal server knew what to do with them. It was an API similar to Servlet API, okay? You could use struts or JSF or a web framework inside of each portlet. And if you use struts in one portlet, you could use JSF in another portlet, You could use some other framework, another portlet, and they would all work on the same page. Okay. And also, one of the other key features of portal servers is personalization. Like, someone might personalize their widgets, their portlets act differently than somebody else. They might have one page that has 5 portlets, and then someone else has another page that has 4 portlets that are different. Okay. But the key thing here, for the perspective of our discussion, is independent of deployment of individual UI applications, right? So this was in around 2003. Okay. We also had the web services for remote portals feature. And the idea there was that, you might have that portlet on your page, but it might be hosted on a completely different machine, right? So you basically have the ability to have distributed little applications running across, different servers and everything. So that was the idea with WSRP. Again, no, that was XML based. The protocol was. Okay, so we get to 2004, and due to some complaints about the way W3C was handling HTML, the Web Application Technology Working Group was created by all the major vendors, basically all the major browser vendors, and they said, "All right, we're going to take HTML forward." And the main reason they started it was because the W3C was pushing XHTML. XHTML was an XML compliant version of HTML, and that's what they were pushing. And that's actually what we all thought we were going to use at the time. However, a lot of people didn't want to do that, so they created the what WG and moved forward with HTML separately. Okay, and they won, because otherwise, if they hadn't won, we'd be using XHTML today. Okay. And so for better or worse, that's the way things are. And then CSS 2.1 came out. But also that year, we saw a few other things. We saw Nginx and Netty. And if you saw my virtual threads talk earlier this week, the main reason they're significant, I think maybe I missed the Apache web server. But the Apache web server had been dominant. It had like 80-something% market share. It was like every web server was Apache, right? But Nginx said, well, if I do an event loop and don't have a thread per request model, I can support more than 10,000 concurrent requests. So Nginx came out and now is much more dominant. Well, I'm not really sure what the numbers are, but I know it's got a huge market share now. And Netty came out on the Java side, same idea. So now we're getting to a point where we're actually building more scalable applications as well, right? And the reason for that is basically because the internet's getting bigger, right? We have more needs. We need more scalability. And the other key thing, we had Ruby on Rails to provide a very opinionated, quick way to build applications, big deal, on the server-side web framework front. And we also had Gmail. Did anyone remember when Gmail came out? Nobody. Wow. Okay. All right. One person. I knew there had to be one person. So Gmail was significant. And the same thing goes with Google Maps a year later, because they really pushed what you could do on the web, and they made use of the XML HTTP requests to do AJAX, right? So they were some of the first applications to really do dynamic UI updates on the web, where whenever they wanted to make a change, they would make a background request, grab some more HTML from the server, and then update the page, right? So they were really one of the first applications to do that. This is also when Firefox 1.0 came out, because Netscape has died by this point. And Firefox is essentially the new version, the open source version of Netscape. We also get, in 2005, we get Django, for another server-side web framework, Google Maps, as I mentioned. This is actually when AJAX term is coined, okay? And this really is sort of the linchpin, sort of the entry into the modern day way we build applications, right? Because up until that point, remember, everything you did was a full page refresh, right? And things like Google Maps showed how responsive you could be if you actually just use this XML HTTP request feature, okay? All right, let me just do that. Okay. And this was when it was that the term was actually coined. Okay. So then we go to 2006. We get EC2 and S3. So Amazon Web Services really starts being very useful for everybody. This is also when we get jQuery. Okay. So now we get a library that gives us, all these great features that make it easy to interoperate with the DOM and do all these sorts of other cool things, do CSS tricks, etc. Okay. And we also get Internet Explorer 7 and the Yahoo User Interface Library, which was sort of like jQuery in the sense of having a lot of extra features, but also had UI widgets and things as well. Okay. But you may notice that this is where Internet Explorer came out, 2006. Does anyone remember when Internet Explorer 6 came out? Let's see here. Let's see, Internet Explorer 6. There it is, 2001. So 2001 was when Internet Explorer 6 came out, and then 2006 is when Internet Explorer 7 came out. So we basically had 5 years of stagnation because at that time, Microsoft had the lion's share of the market for web browsers. And so you get your Windows machine, you launch a web browser, it's Internet Explorer, you thought that's what you were supposed to use, right? And Microsoft said, okay, we're done. We got market share, we're good. And they sat on it until Firefox came out, right? In 2004. And then after they saw Firefox rapidly eating away at their market share, they came out with Internet Explorer 7. Okay. So during that time, the web kind of stagnated because Internet Explorer kind of didn't grow. And we lost a lot of progress we could have had. So 2007, we got iPhone with Safari. This is significant because now we're starting to have real mobile clients, not just flip phones, right? Real actual browsers. There was also Silverlight, which was like Flash and Shockwave, but from Microsoft. 2008, we get our first Android phone. And we also get Chrome, Google App Engine, Adobe Air, which was an attempt to make Flash run on the desktop and have more features, and ECMAScript 5. Okay. So the significance here is that Google App Engine, okay? So at this point, we didn't have Docker and stuff yet, but Google App Engine is actually a platform as a service. You could actually run Java, and I believe there were other languages you could run as well on there. I think they had Python perhaps, but basically you could actually upload your code and have it run on a server somewhere, which is actually a really big deal, okay? So that was really significant. So this was 2008. And then 2009, we get Node, we get WebSocket, so now we have the ability, number one, to write JavaScript on the server, because before you really couldn't do that. And number two, with WebSocket, you have the ability to do push from the server, right? So now we have a point where we have, we've had our forms, right? We can actually make quick requests to the server, and we can do asynchronous updates, do AJAX, update part of the page, right, by getting a payload back from the server. And now we can even do server push, right? And we can also start doing things with Node. So 2010, we got Windows Azure. So Microsoft got into the cloud business. And then that's when we got responsive web design, okay? And this makes sense because now we have lots of Android and iOS phones, right? And it's been important for us to use those media queries, which came out a few years ago, to actually build responsive UIs, okay? 2010 was when we also got Angular, Backbone on the front end, and on the back end we got Express for Node, okay? So now for the first time, we have some actual client-side frameworks that have real functionality, right? So we've gone beyond jQuery, which is great at it was a Swiss Army knife utility library, right? And now we have actual UI, our web frameworks running in our browsers, and that was Angular and Backbone. Okay. And then in 2011, we get Flash gets deprecated, largely because Apple did not want to run it on the iPhone. They said it was a CPU hog, which it was. We get Ember.js. We get a new version of CSS. We get Vertex on the server as another sort of reactive backend platform. And we also get Docker. Okay. So, remember, until now, everything you ran was on its own server, right? But now we're looking at a situation where we're starting to say, oh, we could have lightweight containers, right? And I will say they did have virtualization. So you could get like if you're doing EC2, you would get a VM. It wasn't actually a full-fledged machine, right? So it was still virtualized. It just wasn't as lightweight, okay? But also what we saw around this time was the client-side web frameworks started to have UI components as well, okay? So you could actually have widgets and things for your client-side web framework. So now we've sort of swapped things so that all the UI components are not on the server, they're on the client, okay? 2012, we get TypeScript, which is definitely my favorite way to write web applications. In 2013, we get React, and we also get a whole bunch of other goodness with HTML5 features, okay? And so this is sort of really when things are definitely taking off. We also get Vue, and the Silverlight gets killed as well. And we fast forward to 2015, we get Fetch, HTTP2, GraphQL, Edge, etc. I'm hurrying up because I'm almost out of time here. And then we also get a lot of cloud love, right? We get Open Container Initiative, which is the standard for containers like Docker, right? We get the Cloud Native Foundation to standardize ways of building cloud applications. And we also get Kubernetes for managing containers, okay? And then around 2016, we get Angular, as we know it now. And we also get some other features like Shadow DOM that help build HTML web components inside of the browser, which don't require an actual UI framework, okay? And we also get Next.js. And Next.js was starting to look at server-side rendering after all these years of doing client-side rendering, right? Another thing that happened was 2016 was micro front ends, right? And this is becoming more popular now. But the idea that, we're building these, all of these rich web applications with JavaScript frameworks like React and Angular and Vue, but they're big monoliths. And then we have all these cool microservices on the back end, right? So why don't we actually use that same idea, say, okay, I'm building this feature, and then I will create I will build the UI functionality for that as one application, and then I can deploy that and run it with other applications, right? And each one can have its own build pipeline and its own deployment process, okay? Which sounds somewhat like portal servers to me. A little bit different because there's not a server there's not really as much of a infrastructure built around having the actual micro front-end API or user interface, I should say. But the idea is the same. You can have little widgets, right, or little pockets of functionality, build them separately, and then deploy them and give the user the idea that they're all integrated, okay? So it's sort of a new take on the same idea, okay? And then 2018, we get really much more powerful CSS. Finally, we can avoid doing tables anywhere or fancy div stuff. And we also get custom elements. So now we're at a point where the web initially was built with HTML, right? With certain elements like, body, H1, H2, H3, etc. In 2018, custom elements gave us the ability to create our own elements. You can actually extend the language, okay? So you can write your own elements in JavaScript, and those elements often are UI components, okay? And some of the UI frameworks that you use custom elements underneath or somewhere along the way, okay? So the web has now grown to be very, very extensible. Okay. So our journey ends around 2020, which wasn't too long ago. And we've got CSS grid layout now. So CSS has really gotten to a point where it's super, super powerful. Not only can we use it for web applications, but we can also use it for other sorts of UI applications. Has anyone heard of JavaFX before? One person, all right. So JavaFX is a UI toolkit for Java desktop applications and mobile applications. It uses CSS for layout and everything. And it's not a web base at all, okay? And did anyone know that HTTP 3 is out? Yep. I didn't know either until I started doing this talk. So HTTP 3 came out in 2020. As of last year, it's now available in Safari in every browser. It actually does not use TCP. It uses something called Quick, and it uses UDP, not IP. So it actually uses a completely different network stack. It's faster than HTTP 2. And it also gets around some limitations of HTTP 2. Same rules apply. You don't have to rewrite your applications. This is more of a server browser thing. And also, I'm surprised the number of people that have lately asked me about HTMX. And HTMX takes a different approach to all the things we talked about. It is built in JavaScript, but the way that you use it is by adding special HTML attributes to your elements. And your elements, so you can say any element, you can add AJAX support to it, so it can make a request, and you can do other dynamic functionality. But you don't actually really have to write any JavaScript. And whenever it makes a request, you can get back HTML to do an update, which is essentially AJAX, right? And I've heard a lot of people talk about this, but to me, this reminds me of the frameworks we had, back 10, 15 years ago that did AJAX. But it's out there now. It's actually gaining some traction. So we'll see kind of what happens later. The other thing that we've noticed is we've seen a lot of this server-side rendering talk, right? I know there's been some talks about it here. And it's interesting to me because server-side rendering is another sort of hybrid, right? So initially, everything was server-side rendered. That's how we did stuff, right? Then we went all to the client. We started giving down huge payloads with millions of lines of code of every framework that, for every framework we're using, right? And then we have all our rich functionality, right? But the problem with that is that the time to paint, right, is a long time because you got to ship the payload down and then you got to actually do the rendering and everything. In order to help with that and also help with SEO optimization, because obviously if you're shipping down a whole bunch of JavaScript before you do anything, it's not too SEO friendly, right? Server-side rendering basically says, all right, well, why don't we send you the HTML back and then we'll hydrate your UI components, right? Then we'll give them some functionality. So the initial rendering is done on the server, and then the JavaScript payload is sent incrementally to provide functionality, okay? And the other key feature of this, the other key thing that makes this possible is Node, right? Because before, around 2010, we didn't have the way to write server-side JavaScript. So now these frameworks that are doing server-side rendering, everything is in JavaScript. So you can actually have sort of the same code base that has some client-side rendering and some server-side rendering all together, okay? So that's sort of where things are going now. We'll see what happens longer term. But the key thing here is that, as we grow as an industry, it's important to sort of look and see where we've been before and what sort of the pain points were along the way, when we look at how we're going to build micro front ends, we should probably also look at, how we built portal servers, what didn't work about that, why did it fail? And a lot of things that just have to do with different forces, internet got better over time, different technologies emerged, cloud computing emerged, et cetera, et cetera. So I want to encourage you as you move forward and build applications, to sort of not only think about what are we doing now, what have we done in the past, what works now, what doesn't work, or what didn't work before, okay? All right, so with that, I think we are out of time. Thank you very much.